This is Alan Elliott, and this is SAS Essentials Mastering SAS for Data Analytics, 3rd edition. In this chapter, Chapter 7, Part 1 of SAS Advanced Programming Topics, we're going to be learning how to use and create arrays, do loops, and the retain statement. In Part 2, we'll look at SAS macro variables and macro routines. As usual, if you'd like to follow along with examples, please make sure you've downloaded the files from this location. Okay, let's get started. Right, section 7.1, using SAS arrays. A SAS array is a statement that provides a method for placing a series of observations into a single variable called an array. Often these arrays are referenced as part of a do loop, which is a technique for iterating through a dataset that we'll look at later in this chapter. A simplified syntax for SAS arrays is as follows. So use the array keyword, array, and then some array name you assign, some subscript that you choose, a $sign if it's going to be a character array, and optionally some array values. Let's drill down and see how that works. So first let's start with one-dimensional arrays. A one-dimensional array are specified with array statements such as array, and then time is the name of the array. 1:6 says that it's going to have 6 values from 1 to 6, and we're going to give it some names. Time1 dash time 6. That means the names are going to be time 1, time 2, and so forth. So this array creates an ID array called time with an index value indicated in the parentheses. So time 1 is going to be the value of the variable time 1. Time 2 is going to contain the value of the variable time 2, and so on. So 6 values are assigned to the variables time 1 through time 6. Another way to specify this same array as above is just by saying array time and the 6. It assumes the 1 colon there. So you'll see that those are both the same thing. All right, so we can change the beginning and ending index value of an array using this kind of statement. So if I say array time 0:5 and then 5 variables here, or whatever 6 variables actually, then the index for them starts with 0 instead of the normal 1. So in this case, time 1 is equal to whatever the value of A is. Time 1 is equal to the value of B, and so forth. So notice that in this case, the index begins with 0 instead of 1 because we set that initial array size in the parentheses 0:5 as the beginning and end of the index values for this array. We can also define an array with an unknown number of elements. For instance, look at this example, array answer and then an asterisk within parentheses Q1 through Q50. So in this case, answer 1 is going to be equal to the same value as Q1, answer 2 is going to be equal to the same value as Q2, and so forth. The size of the array is not specified, but SAS figures it out according to how many items are assigned to the array. I'm going to stop for just a moment and explain why we need array values if they're equal to some other value that we already have. So for instance, answer 1 is equal to the same value as Q1. Why do we need that? And the answer is sometimes within programming, for instance in the do loop that we described earlier, it's handier and much easier to refer to a value using an index value, sort of like answer 1, answer 2, and so forth. And we can loop through them or we can refer to them much easier than we can to a fixed variable name. And we're going to see how that works as we move along. All right, let's specify some text value arrays. So in this case, array answer 1 through 5, as we saw earlier. But now notice there's a $sign there, and that says that Q1-Q5 are no longer numbers. In all the previous ones, all the variables were assumed numbers because we didn't specify that they were a character. Now the $sign here says they're a character, string, text, whatever word you want to use. values. So Q1 through Q5 are now text values. And these text arrays are created the same way. The only difference is we have that $sign there to specify that they're character. Another thing you can do when you're defining an array is you can actually define the initial values or actual values in an array. So here's another array. Array value 5. So this is going to have 5 components to it. And by the way, down below I mentioned that you can use the brackets, all 3 kinds of brackets. They all mean the same thing. So don't worry about that when you're defining an array. But we do put the values of that we're going to assign in parentheses. So this array specifies actual values for the array. So in this case, the value 1 item within the array is going to be equal to 2. Value 2 item in the array is going to be equal to 4, and so forth. So we can see how that works. So if you want to create an array and at the same time specify the values for each item in the array, you can do that using this technique. All right, you can also specify character values for an array. So here we have an array we're going to call fruit. And notice instead of just a $sign, I have a $10. That's actually like a format. So I'm assigning it as a character value with up to 10 characters in the value. And then I'm going to specify some values. So notice here, since they are character values or text values, I'm going to put them in parentheses, no commas between them. So I have apple, orange, and lemon. So fruit 1 is going to have the value apple, fruit 2 is orange, and fruit 3 is lemon. So this is a way that you can specify character values within an array. Now you can also specify no values in an array. So here's an array I'm going to call ABC, and I'm going to give it 5 array values, but all the values are going to be missing because I haven't specified anything. I haven't specified either variables or values here. So all of the entries in this array are going to be equal to missing values. Sometimes you want to create that array and then you're going to fill in maybe the values later. Now let's look at some more examples. Here I'm going to specify both variables and values in an array. So here I have an array I'm going to call drink size. Notice here I'm not specifying the size of it, although there's obviously 4. And there are 4 variables. So these are variables. These aren't text values. So notice they're not in quotes. So these are actual variables: small, regular, large, mega. And now I'm going to give those an initial value. So drink size 1 is going to be 8, and drink size 2 is going to be 16, and so forth and so on. But they also have variable names: small, regular, large, mega. So now I've created sort of 3 things at once. Here's another one: cup size. And again, I'm going to create cup 1 through cup 4 as my variable names, and I'm going to give them these 4 actual initial values. So notice down below, I have drink size of 1 is equal to the value of small, which happens to be 8. In the second one, cup size 1 is going to be equal to the variable cup 1, which we assign the value 8. Now, if we create an array without an array specification, with just the asterisk, there needs to be a way to tell what is the lower and upper bound of this array, and so SAS gives us that information. So in this case, the upper bound is set to the value of whatever the dim of that value is, the dimension of the array. In this case, it's 6. And we have these functions called L-bound of the array name that represents the lowest index in the specified range, and H-bound of the array name. Now, in this case, the array name is time, and it represents the highest index. So again, we can refer to these if we need them programmatically. All right, so let's referring to values in an array. Let's use some values in an array to do something with them. So once an array is created, such as time, you can then refer to that value in the array by specifying an index value and use that value any way you would use a regular variable in a statement. So for instance, new value equal time of 5 divided by 365. Now if time 5 is equal to the same thing as the variable called time 5, then we could have said new value equal time 5 divided by 365 would have been the same thing. But again, sometimes we need or want to have the ability to use an indexed value rather than the actual variable. And again, we'll see some examples as we move along. All right, this is our first example. If you'll open up the program called darray1.sas, this example illustrates how to use an array statement. So here I'm reading in a data set called A that consists of 4 variables, 1, 2, 3, 4. And I'm creating an array called T, where the values of T are 1, 2, 3, 4. Now I'm going to use do some calculations here. I'm going to call T sum 1 is equal to the sum of 1, 2, 3, 4. Now if you'll refer back to a previous tutorial, we should know that the of means that if there were some missing values in here, it's still going to sum them up for us. So T sum 1 is the sum of, and I list out the 4 variable names. T sum 2, instead of listing the variable names, I'm going to list the array names, T1, T2, T3, and T4. And then finally, T sum 3 is the sum of, and I just give T asterisk within parentheses. And then I have some data lines there. So what we're thinking that this is going to do is sum up the values within a row, 1, 2, 3, 4, add those up. But do they differ? Does T sum 1, 2, and 3 differ, or are they doing the same thing? So here we see that they are actually doing the same thing. So we see that summing up 1, 2, 3, the values of 1, 2, 3, 4 is the same as summing up the values of T1, T2, T3, and T4, or a shorthand method, the sum of all values in T. And as we can see here in the output, T sum 1, T sum 2, T sum 3, they all three have the same values, 10, 26, 10, 26, 10, 26. So we see that they all calculated the same thing. There's some other steps in this hands-on example. I encourage you to do that within the text. Okay, let's look at hands-on example 7.2. This example illustrates how to use an in statement with an array. So we want to find the word orange in the array we create. Let's open up the program file called darray2.sas and we see this code. First of all, we're going to create the variables 1, 2, 3, and 4. They're all character variables and we're going to assign a length of 10 to each one of them. Then we're going to create an array called fruit with 4 entries in it. And those 4 entries are the variables 1, 2, 3, and 4. Now that we have an array, we can search that array using an if statement. So here we say if orange in fruit, then is orange equal 1, else it's 0. So what that does is as it reads in the data, it's going to look at all 4 values in the fruit array, and if any of them are the word orange, then it's going to set the variable is orange equal to 1, which typically we use 1 meaning yes. Otherwise, the value is going to be 0. So let's look at the data below data lines. Here we have 2 records, and we see that there is an orange in the first record, the word orange, which is going to be in the variable 2, TWO. So hopefully what we're going to find is that it's going to search through this and find the word orange in the first record, but not in the second. So let's look. So here we have our results, and we see that we have a new variable created called isOrange, and it's 1 for the first record and 0 for the second record, because there we have orange, the word orange, within the array that we created for the and then when we read it in the first record, it saw the word orange, therefore we found it. So this allows us to do a search of an array. It becomes very handy if you're looking for a particular value within an array. There's some other steps to this example, and I encourage you to complete them in the text. Now let's look at section 7.2, using do loops. Now, if you've done any programming in any other language, you already know what a do loop is, but let's talk about it. So a do statement is a way to control the flow of your program. There are a variety of do loops available in SAS, and we're going to look at some of those. We have an if and do, where we use a do in an if statement to cause a group of statements to be conditionally executed. We have an iterative do loop. We iterate through a series of statements based on some incremental index. We have a do until, where we execute a group of statements until some condition is met. And then we have a do while, where we execute a group of statements as long as some condition is true. And just a little note here, the if and do combination we already discussed in chapter 4. All right, so let's look at the iterative do loop. An iterative do loop is a way of incrementing through a series of statements based on some index. So a simplified syntax of that is shown here, where we say do some sort of index value is equal to some initial value to an end value, and then an increment value. So let's look down below where we see, first we're going to set a sum is equal to 0, just because we're going to use that to add some stuff to it. And then let's look at the do loop. Do, then we set a variable called iLoop. We choose that name, iLoop, whatever we want to choose. And that loop is going to now go from the values 1 to 4. And the normal increment is 1, so it's going to go 1, 2, 3, 4. It's going to loop through until the end statement. So it's going to do whatever's between do and end 4 times. The first time through, sum is 0, iLoop is 1, so it's going to add 1 to the value and put it in sum. And then it's going to loop through again and again and again, accumulating values of sum as it goes along for 4 times. Now let's look at how that worked. So let's follow the code. Since initially sum was 0 and the first value of iLoop is 1, then the first time through we have sum equals 0 plus 1. So sum becomes the value 1. Then the subsequent loops are sum was now currently the value 1, but iLoop is 2, so 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4. So the final sum at the end of the loop is 10. And it's handy to go through here and do a few of these by hand just to understand what's happening within the loop. Now we also have a do until type of loop. And in this loop, the increment is replaced with an until clause with, in this case, iLoop greater than 4 in parentheses. For example, we're going to set iLoop equal 1. It's going to be our first loop. Again, sum is 0. Now we say do until iLoop greater than 4. So iLoop is currently 1 the first time through, so it passes the condition, and then it does the value here, sum equals sum plus iLoop, similar to the previous one. And then we're going to increment iLoop plus 1. That means that's a short way of saying iLoop equals iLoop plus 1, just iLoop plus 1. That SAS allows us to do that. So we hit the end statement. It goes back to the beginning. So now the second time through, iLoop is 2. It continues, iLoop is 3. And then it continues, iLoop is 4. And then finally, when it says iLoop is greater than 4, it stops. So it continues to go through the loop until a condition is met. Sort of similarly is a do while. This loop continues until the condition is no longer true. So it does a similar kind of thing, but a different way of looking at it. In this case, we still started with iLoop is 1, sum 0, but now look at the loop. Do while iLoop less than 5. So again, we're going through here, incrementing our iLoop, and it goes through 1, 2, 3, 4, as long as it's less than 5. But when it hits 5, it no longer is less than 5, so it ends the loop. So whatever makes sense for you in terms of reading through, going through a loop to do some calculations or whatever you want to do, you can use any of these kinds of ways to iterate through a series of statements. So let's do hands-on example 7.3. This example illustrates the do while loop. So open up dwhile.sas, and we see we're creating a data set called temp, setting n equals 0 and square sum equals 0. And then we have do while n is less than 5. And now we're going to do the calculation square sum equals square sum plus n squared. And then output. Let's see what that means in just a second. and then we increment our counter, n plus 1, and it hits the end statement. So it goes back up to the do, continues with the new n. Now the second time through it's 2 squared, then 3 squared, then 4 squared, and so forth until it is no longer meets the criteria in the while, and then it stops. A brief note about the output statement in this code. Why do we have it here? Well, notice here we're creating a data set called temp. We're not reading in any data at all. Instead, we're creating data through the do loop. And so since we're creating the data, we need to tell SAS every time we create a new data value or record, like we're creating square, sum, and n, then we would use the output statement here to say, okay, I've created a data line, now output it. And so through each loop of this do loop, it's going to output a new data record. Okay, let's look at the results. So as we see, I have some of the code on the left here and then the results on the right. And the first time through, n is 0, so square sum plus 0 squared is 0. And then the second time through, n is 1. 1 squared is 1, so we have the square sum is equal to 1. Second time through, n is 2, so n squared is 4, plus that 1 makes the result 5, and so forth until we hit 30. So again, you can walk through this, and it's a good idea to do this by hand a couple of times just to understand how this is working. So let's look at do loops with arrays. So one of the most powerful uses of do loops is realized when we use it in conjunction with an array. That's why these items or these topics are together. For example, suppose you take 5 systolic blood pressure readings on each subject. Suppose that if any of these readings is above 140, you want to classify the subject with a value high BP equal 1, or else the subject will have a value high BP equal 0. The following code could perform the task, and we'll look at that in just a second. But again, let's look at what we're doing here. We have 5 readings, and we say if any of them meet some criteria, then we're going to capture that information and call it high BP equal 1. Otherwise, if all of the readings are under 140, then it continues to be high BP equals 0. All right, so let's look at the code to do that. We have a data set called pressure where we're reading in some data already created. We have an array called SBP with 5 components to it, which are reading 1 through reading 5. We set high BP equal to 0, and then we begin our do loop. So notice we have a do and an end, and we say do I equal 1 through 5. If SBP is greater than 140, SBP of I, so that's important, that increment there. So the first time through, I is 1. So it's saying if the first reading was greater than 140, then set high blood pressure equal 1. If that's not the case, nothing happens. Then it goes through the loop again. If systolic blood pressure of reading 2 was greater than 140, then set high blood pressure equal 1. So it continues with this loop. If any one of the readings was greater than 140, then high blood pressure was set to 1. Here's a similar example using a text array. Here we have data new, set old, and I'm creating an array called answer. Maybe this is some sort of questionnaire where there's 50 questions, and each question is given in a variable Q1 through Q50. And so I go through a do loop, and I want to maybe, we're looking for answers, but if the answer is NA, that means that there wasn't an answer. So we want to reclassify NA with a blank answer for some analysis that we're going to do. So I say if answer of I is NA not available or something like that, then I'm going to reset the answer I equal blank. So this is a way to look at your, integrate through all 50 questions. This becomes very, very handy. Otherwise, you would have 50 different if statements to do the same thing. So by being able to iterate through an array, I can do this in only 3 or 4 statements. Okay, let's look at hands-on example 7.4. This example illustrates a simple use of arrays and do loops together. So we want to know the value of a reading at a subject's last visit to a clinic. Notice that there's a number of visits and they differ by subject. So subject 1 had 5 visits. Subject 2 had 3 visits and then some missing values. Subject 3 had 2 visits, a missing visit, and then a visit, and then another missing visit. So what we want to do is create a column that gives us the value of the last observation read for a particular subject. So let's see how we can do that. Open up the file called ddoloop.sas, and you'll see that this is the code. So we're creating we're looking at the data set called clinic, and we're going to input the ID number and the visit 1 through 5, and then we're going to create an array with 5 values in it, visit 1 through visit 5. We're going to set the last visit as visit 1. Everyone had at least one visit to begin with, so we set that as the default value for last. And then we go through a do loop, and each time a record is read, we do this test. So as it goes from 1 to 5, if the time, for instance, of 1 is greater than 0, then we say, okay, that's the last time. Then is time 2 greater than 0? Okay, then that's the last time. Is time 3 greater than 0? If it is, then that's the last time. Is time 4 greater than 0? Oops, that one's missing, so we just skip it. And so what we're going to end up doing is capturing the last value that had an actual time in it. And when we finish that and run it, we get this result. And so we see here the 5 possible visits, and then notice here the last column contains the value of their last visit. So there's some additional steps in this hands-on example. I encourage you to go to the text to finish it. Now let's look at hands-on example 7.5. In this example, we're going to show how to use an array when you don't know the upper and lower bounds. So in this case, open up darray3.sas, and this is going to reuse some crime data from Washington, D.C. from the 1978 forward. And notice here we have a number of incidents that have been recorded. And but we don't know how many there are. They start with violent and end with car theft, but we don't know how many columns there are in this. So we're going to say incidents with an asterisk there, which we're allowed to do. It just says we don't know how many there are. So when we do the do loop, since we don't know the beginning and the end, we say I equal L bound of incidents, lower bound, to H bound, or highest bound incidents. And then we're going to add up. Total equals sum of total of whatever the incidents were. So, and there's other ways to do this. We're just showing this as an example of one way to do it. And then we end. We're also dropping I because in our final output we don't want to necessarily see that increment variable. All right, and this is the result we get. Notice here we have year population index, and then violent through car theft. Those are the types of crimes that were noted, and what we want to do is add them all up. So indeed we have a new column called total that should be the sum of violent through car theft for each record. So that's how we would do that. I might mention that there are some what we call quick notes for SAS arrays, and they are available at this website, alanelliott.com/SAS, and just drill down to where it says quick notes. And these are 8.5 by 11 sheets that you can print out, maybe double-sided, and it has a lot of the information that we've talked about for using SAS arrays, and it just gives you a quick guide to help you when you're beginning to use arrays in your SAS programming. All right, let's look at section 7.3, using the retain statement. Now the retain statement is used in a data step, and it allows you to keep values or retain values of a variable across iterations as the data records are read into the data set. If you remember, in a previous tutorial, we talked about how SAS read the data, and every time it reads a record, then it zeroes out the data array and begins to read a new data record in. Well, what if we don't want it to get rid of all the data we just read in? and we want to retain it for the next row of data, then we can use the retain statement to do that. And the format is retain and then variables and initial values. For instance, if we want to retain the value of score from one record to another, we can just say retain score, and this would be before we actually read in this value. Okay, a statement can also be of this type, where we retain time 1 through time 10, score and visit date. So you can list as many values or variables as you want to retain. By default, the initial value of a retained variable is missing, but we can set it to a value. So if I say retain score 1, then it's going to retain score from record to record, but it's going to start with an initial value of 1. We can also do this with text variables. Here we have retain category none. So category is a text variable, so the initial value for it is none. And then we can also assign it to a number of variables at once. So time 1 dash time 10 0 means that apply the original or initial value of 0 to all 10 of those variables. And a few other things here that are of interest. We can also, these three statements actually do the same thing, but retain time 1 through time 4, and we're going to give it a list of values to begin with. So time 1 gets the value 1, time 2 is 2, times 3 is 3, and times 4 is 4. Or we can list it with commas in between, or we can actually list it like this, 1:4, and that will fill in all the initial values for time 1 through time 4. Now, if we want to retain all the variables from record to record, we can use this special variable name that's embedded in SAS _all_, which means all variables in the data set. Okay, let's look at hands-on example 7.6. This is an example of using the retain statement. So here we have a data set we're calling days, set my data. Now, what we're going to do is first read in a value. So this if underscore in of underscore, that's a special SAS variable that means whatever record value we're reading in at the moment. So if n equal 1, that means the very first record in the data set. So this would be observation 1. So if we're reading in observation 1, then set the value of first to visit date. So when we start reading through this data, it's going to encounter the first record, and it's going to store January 4th, 2015 into the variable called first. Now we're going to say, okay, now retain first throughout the rest of the data set. So now we're going to, as we read in the data, here 2, 3, 4, 5, we're going to calculate a value. Days equal visit date minus first. Now notice here that it's retaining first. These are the results after we run the program. So this was the original date. This is the date called first that we see now it retained. And then it subtracts this date minus this date in 25 days difference. And so if we had a data set and we wanted to know, for instance, for subjects, how many days has it been since they've been in the clinic or other kinds of ways, we could certainly do it that way. And again, there's some additional steps in this example that you could do from the text. Now, another one. Let's look at example 7.7. Open up the file called dretain2. In this case, we're going to read in a data set called lemon and input day sales. And this time, if n equal 1, then total equals 0. So here again, we're going to read in the first value here, and we're going to set, the first time through, we're going to set the value of total to 0. And we're going to tell it to retain total and max. Now, the reason we set it to 0 is because we're going to do this calculation here, where I say total equals sales plus total. So if I had total equals sales plus a missing value, then it would give me a missing value. So I don't want that to happen. So I say total equals sales plus total, and I've set total to 0. So total is going to be equal to total, and so we get the initial value here. Then I say if sales is greater than max, then max equals sales. So here I go through here, and if sales is greater than this value here, then I'm going to up it to whatever that value is. So here it read 32.5. That's greater than max. So it put max or sales. You put max as 32.5. Now the next one it reads is 19.8. That's not bigger than max, so it doesn't do anything. It just retains the whatever was there, and so on and so forth. So again, this one has several other steps in it that you could do in the text. Okay, this is a summary of Chapter 7, Part 1, where we looked at creating SAS arrays, do loops, and the retain statement. In Part 2, we'll introduce SAS macros, specifically macro variables that allow us to create generalized variables, and macro routines that allow us to create code we can use over and over again. I hope this tutorial was helpful. If it was, please subscribe and click the like button. Thanks.